Data structures. A data structure is a way of organizing data in a computer so that it can be used effectively. For example, we can store a list of items having the same data type using the array data structure. Linked list data structure. A linked list is a linear data structure in which the elements are not stored at contiguous memory locations. The elements in a linked list are linked using pointers as shown in the image. A linked list consists of nodes where each node contains a data field and a reference or link to the next node in the list. There are three types of linked list: singly linked list, circular linked list, doubly linked list. A linked list is represented by a pointer to the first node of the linked list. The first node is called the head. If the linked list is empty, then the value of head is null. Each node in a list consists of at least two parts: a data part and a pointer part or a reference to the next node. Operations on singly linked list. Insertion at the beginning, insertion at the end, and insertion at a given position. Insertion at the beginning. So, to achieve this, we need to consider two cases. That means a case one where the head points to null. That means there are no nodes in the singly linked list. That means no list itself, only head, and head points to null. Okay, and the second case is there is a linked list, there is a list, and head is pointing to one node, and then that list continues. And the first node points to the next node, and the second node points to the third node. So insertion at the beginning. Case 2. That means we are having a head and it is pointing to null. So what we have to do, we need to insert this node to this head node. So what we have to do, we need to assign the address of this node to this head. Okay, so it's very simple. Just assign, and we'll just copy the address of this particular node or the memory location of this particular node to this head, and thus we're finished. This is the first case. Insertion at the beginning of a linked list. Another case. Suppose we are having a linked list with so many nodes. So head is pointing to the node, the first node. First node points to the second node, and second node points to the third node, and so on. Okay. Suppose we need to insert a new node to this particular position. That means we need to insert this node at the beginning. That means head must point to this new node instead of pointing this old one. So what we have to do, we need to remove this link, and we need to attach, we need to add a connection between this head and this new node. Okay, so we need to remove the link, and then we need to establish a connection between the head and this new node. Okay, so now we get a new singly linked list where a head is there and only one node, a new node, and these nodes are now not reachable because how can we reach this node 1? This node 1 can't be reached. Okay, so this is not the condition what we need. This is not the requirement what we need. Okay, we need to insert a new node in between head and the first node. Okay, and so what is the solution? So in order to get these nodes accessible, we need to get a connection from this node to this node, that node 1. Okay, so what we have to do, we need to copy the address of, we need to assign the address of this node to this pointer part. Okay, so if we do like this, we achieve our requirement. So head now points to this new node then points to the previous first node, that is node 1, and then it goes. Okay, so how can we implement this in our code? So suppose we know that earlier this head contains the address of this first node, this node 1. Okay, so now previously head contains the address of node 1. This is the first node. Okay, so what we did, we assign the address of this new node to head. Okay, then what we did, we assigned the address of this first node to the pointer part of the new node. Okay, so but how can it be possible? From where we'll get the address of node 1? So this address of node 1 is no more available, because it is only available in this head that we it is removed when we store the address of this new node. So we need to think in a different way. So first of all, we'll be copying the content of head to a temporary variable pointer, say temp. So the address of this node 1 is now available in temp, and then we can assign the pointer part of this new node with the address of this node by using temp. So now the problem is solved. So this is the logic to implement the insertion of a new node at the beginning of a linked list. Insertion at the end. That means we need to attach a new node at the end of the existing singly linked list. Here also we have two situations. First one, we are having a full-fledged singly linked list in which many nodes are there. Head is pointing to the first node, and what we have to do here is that we need to find the last node and then attach the new node to this last node. Another case is there are no nodes in a linked list. That means the head is pointing to null, and in this case it is very easy to attach a node as an end node. Okay, so just copy the address of the new node and assign it to the head node. Insertion at the end. Here we have a linked list, and in which we can see 3 nodes are there. Now we need to insert a new node. Suppose this be the new node, and we need to insert this as the last node of this singly linked list. For that, what we want to do is that we need to traverse from the head to the last node. Okay, how can we check that? We first of all we go to head, then there only we can find the address of the next node, and from that node only we will get the address of the next node, and then from there next node. So from here there is no address of the next node given. That means this is the last node where the pointer part is null, that points to nowhere. Then what we need to do is that we need to give the address of this new node at this particular point. So now we can attach this new node as the last node of this particular linked list. Okay, now how we are going to implement this using a programming language. Okay, so first of all we need to find the last node. We need to traverse the list until we find a last node. So how to find the last node, how to check the last node? We can check the last node like this: last next is equal to null. Last next എന്ന് പറഞ്ഞാൽ എന്താ? We are assigning this head to another pointer called last, and then we are searching from one node to another node. That means we are updating every time by last is equal to last node next. Okay, so when we are here, last is equal to head. Okay, and when we reach here, the last will be updated as last is equal to this last dot next. So which address is given here is assigned to last. So we will reach here, and then again we are updating last dot next. That means the address of this node is assigned to last. Okay, and here when we reach here, we find that this particular pointer is null. So this is the last node here. What we need to do next? We need to change this address part part to address part as the address of this particular node by writing last next. This is the last now. Adinte next is equal to new node. In new node inde address vechi idu assign cheyana cheynathu. So this is how we implement insertion of a new node at the end of a list. Insertion at a given position. Suppose we are having a linked list like this with 3 nodes. Here it is 3 nodes. Suppose I want to insert a node like this at a particular position. Suppose I want to insert this node at this place. That means at position 2. First of all, I have to remove this link and then I have to copy copy the address of this node to this particular pointer, and from here I need to connect, I need to copy the address of this location to this particular part of the node. Okay, this is the concept of this insertion at a given position. Now how we are going to implement it. Okay, suppose the linked list is this, and this is my new node, and I want to insert this new node at position 2, and that means 1 2. Okay, so for that I just declared a pointer of type node last, then temp, then ptr, and I assigned this last and temp with head. Now head, last and temp contains same content. That means all the 3 pointers points to this particular node, to this first node. Okay, now I'm going to initialize a variable counter as 1. Okay, to check whether I am in a to compare this position and counter, I just used a counter variable. And then next I'm going to see last next not equal to null. That means I'm going to traverse from the beginning of this list. So until when I'll be traveling until I reach null. Okay, so my condition is I'll be moving, I'll be traversing from one node to another until the last next not equal to null. Adu null aguna vareyum njan ee attam vareyum poikondeirikkum. Okay, that is the condition. So when consider this, now last now points to this location. So I'm checking last next is not equal to null. Yes, it is not equal to null because it contains the address of this node. Okay, so it is not equal to null. So I'm going I'm getting into a loop. Okay, and in that loop I'll be checking 3 conditions. One is if position is equal to 1, I'm checking whether the position is 1 or not. Yeah, no, the position is 2, it is not 1. So I am not going to enter into that particular block of code. This position is equal to 1 means insertion at the beginning, so that we discussed earlier. Okay, and if it is not that, what I'll be doing? If the position is not is equal to 1, so I'll be incrementing my counter to 1. Okay, by 1. So now counter is equal to 2. That means now I am in this node. That means I'm in the first node. So next what I'm doing, I'm incrementing. So I'm going to this second node. Okay, so now counter becomes 2. Then I'm assigning this temp with last. Okay, so now temp points to this last. It is last. Okay, and then last is equal to last dot text. Last is now here. Now last is assigned with this address. This address means this. That means now last points to this particular node. Okay, now last points to this particular node. Okay, and then what I'm doing is that whether my position is equal to counter. I'm checking whether POA is equal to counter. Yes, position is 2, counter is also 2. Okay, so this is the second position where I want to insert this node. Okay, so what to accomplish this, what I have to do is that I have to remove this node, this link first, and then So before that, I want to store the address of this particular node. So I use ptr. Ptr is equal to temp. So what temp contains is copied to ptr. So ഇത് എനിക്ക് save ചെയ്ത് വെക്കാൻ വേണ്ടിയാണ്. പിന്നീട് എനിക്ക് ഇവിടേക്ക് കൊടുക്കേണ്ടത് ഈ address ആണ്. So I'll be using this ptr. So I'll be storing this address in ptr. Okay, then what I'll be doing, I'll be removing this link and I'll be giving this link to this particular position, right? Okay, so now this temp dot next contains the address of new node. Temp is equal to new node, and then new node in the next part എന്തായിരിക്കണം, this particular node. So the address of this particular node is stored in ptr. Okay, so new node next is equal to ptr. Now no matter. Okay, and ഇത് ഇത്രയും കഴിഞ്ഞാൽ if equal to pose equal to counter ആയി കഴിഞ്ഞാൽ അവിടെ വെച്ച് നമ്മൾ അത് ബ്രേക്ക് ചെയ്യും, and then otherwise ഇല്ലെന്നുണ്ടെങ്കിൽ will be going till null. Okay, ഇനി അതല്ല, ഇതൊന്നും ഇല്ല, 3 എണ്ണേ ഉള്ളൂ, എനിക്ക് 4ാമത്തെ പൊസിഷനിലാണ് എൻട്രി ചെയ്യേണ്ടതെന്ന് വരുന്നെങ്കിൽ 3 വരെ കഴിയുമ്പോഴത്തേനും ലൂപ്പിൽ നിന്ന് ഔട്ടായി വരും, നള്ളാകുമ്പോഴത്തേനും അത് സ്റ്റോപ്പ് ആവും. So I'll be checking with another condition, pose is equal to counter plus 1. Okay, if it is like that, I'll be adding it like insertion at the end. Same concept will be using here. Okay, ഇതുപോലെ ഒരു simple concept ലാണ് ഞാൻ